Okay, today we're going to be talking about 2.6, which is transformations of functions. Transformations of functions is a super important concept that you need to understand. You're going to hear me say the words up, down, left, right, stretch, compress, reflect a ton. And we kind of touched base on it a little bit whenever we were talking about the absolute value graph. So we're going to kind of expand upon that today. All right, a parent function is a function that is in its simplest form, okay? And we have 5 different parent functions that I need your brain to memorize the shape of what they look like as well as the equation. We have y is equal to the linear y is equal to x, which is just a line going through the origin. We have the absolute value of x, which we know to be a v graph or a valley. We have y equals x squared, which is the quadratic function, and it looks like a u. We have a cubic function, which looks like my spaghetti function. It's kind of look like a piece of cooked spaghetti you throw on the wall. And then we have the square root function, and this is what I call the one-armed bandit. It is the parabola turned on its side and drop one of the lovely little arms. So that's what that is. Okay, so those are the 5 functions that I need you to memorize and understand what they look like. In addition to that, I need you to understand that what we're going to learn today goes for every function I'm talking about. So all 5 parent functions have exactly the same qualities, okay? They have the same transformations. Now, this page right here is a super important page, and you should remember this formula a little bit from whenever we did absolute value. F of x is just function notation. Then we have the negative here. The negative is responsible for the reflection. Remember whenever we did absolute values, it was either going to be a mountain or a valley. If A was positive, it was a valley. If A was negative, it was a mountain. That is the same holds true. So reflections are going to be, if it's negative x, if the negative is on the outside, it's reflected over the x-axis. If the negative is on the inside, it's reflected over the y-axis. Okay? Then we have the A value, which is responsible for the stretch and compress. The stretch and compress is whenever I was talking about our travel mug versus our cereal bowl. Remember, a stretch is whenever you stretched out the coffee mug and made it into a travel mug to put into your coffee holder in your vehicle, okay? Then the cereal bowl is the same concept, except for we're smashing it down, and that means the trash goes out and it spreads out into the trash bag a little bit more, creating more surface area, and it's short and fat, okay? Now, with that being said, that is responsible for the stretch and compress. Now, if you recall, it was a stretch whenever it was greater than 1. It was a compress when it was a fraction between 0 and 1. Now, the next thing what you're going to see here is going to be this negative on the inside. That is responsible for reflecting over the y-axis. So if the negative's on with the A, it's over the x. If the negative's on the inside, it's with the y. Then we have the h value, which shifts it left and right. And it's the opposite of what your brain thinks, okay? So if it's minus inside here, it's actually going to the right. You think it's going to the left, it's going to the right. It is the opposite of what your brain thinks. And then the last one is going to be right here. This is your K value, and it is responsible for shifting up and down, and it is exactly what you think it is every time. So this page talks about every little value that we have there. So if I give you this parent function, I give you y equals x, which is going to be right here. That's what that is. And I give you this lovely little xy table. But then I'm going to talk about what x plus 5 is. Well, x plus 5 is going to do something else, and so is x minus 2. X minus 2, this minus 2 at the end drops it down 2 units, so it's going to go down 2. So this plus 5 at the end here is going to go up 5. This 3x, we're going to compare it to 3x minus 10. Well, look, the 3x's and the 3x's are the same, so what our brain needs to focus on is the minus 10. What is happening to the minus 10? It's actually moving it down 10 units. Okay, that's what's happening here. Same exact thing with this parent function. I give you x squared, which is right here. And then I'm going to give you x squared plus 4, which is inside. All it's doing is it's popping it from 0, 0 to 0, 4, from 1, 1 to 1, 5, from 2, 4, add 4 to 2, 8, from 3, 9, add 4 to 9, that gives you 13 to 3, 13. So it's changing it and it's going up 4 units. Same thing with here. 5x cubed and 5x cubed. This one has the -2, so that means it's going down 2 units. So what I've just showed you is the k value and how it moves it up and down, okay? So what happens whenever I do left and right? So I have horizontal shifts. In horizontal shifts, it is the opposite of what you think it is, okay? So I give you absolute value of x, which the absolute value of x is going to look like this. And then x minus 5, you think it's minus means to the right or to the left, but is actually to the right 5. So 1, 2, 3, 4, 5. Now that's what that graph looks like. Okay? So it's opposite of what you think. So how are the following graphs related? This is the parent function, and it's going +2. So opposite of plus is minus, so that's left 2. Okay? 5x cubed, this is going to be your parent function. It looks like a piece of cooked spaghetti. But now I have -2, so it's minus. So if you think it's going to the left, it's actually going to the right 2. So it's just taking that whole graph and going like that and moving it to the right. Okay? Keep going. A stretch multiplies all of the y values by a function of the same factor by the factor greater than 1. Has to be greater than 1. So a stretch to become a travel mug, you have to have your a value bigger than 1. Okay? A compress or a shrink, same thing, reduces the y values by the same factor, and it must be a fraction between 0 and 1. It has to be between 0 and 1. Okay? So, next is going to be reflections, and we've kind of talked about this already. It's either going to flip the graph of the function across the lines or across the x or y axis. Now, if it's across the x-axis, it's outside. It's with the a. Okay? When it is not with the y-axis or with the x-axis, it's with the y-axis, and you're replacing x with negative x. Okay? So, this is an example of how I want you to do tonight's homework. It is exactly the way I want you to do tonight's homework. So, you're going to take it step by step, and you're going to use the same letters that I'm using. U is up, D is down, R is right, L is left, S is stretch, C is compress. Those are the letters I want you to use. Now, tonight's homework is going to be very similar to this. I'm going to ask for the parent function. The parent function comes from whatever power you have. So that is going to give you the x squared function. Then the vertical shift is your k value. So what is the k value here? The k value is going to be -8, which means you're going down 8 units. The horizontal shift is going to be what's inside. So what's inside is going -2, so you think it's going to the left, but it's actually going to the right 2 units. And then this right here is the stretch or compress. It's one or the other. It can't be both. It deals with this value right here. So that is going to be a 3. So it's greater than 1, so it's a stretch of 3. And then the reflectives, if you're going to tell me if it is going to be over the x or the y-axis or none. Since it is a positive 3, there is no reflection. And since this x is unchanged, there's no reflection. So I'm going to do this one more time, but I'm going to go ahead and go from left to right. The 2/3, the parent function is the very first thing I want to talk about. That's going to be the x cubed. Now let's go from left to right. The 2/3 is my a value, so that means it's going to be a fraction, so it's compressed 2/3. The +6 is the opposite of what you think, so it's left 6 units, and +5 means it's going to go up 5. Now, that's the only thing that's happening to this graph. So we're going to put that in here. So what's my vertical shift? Well, I went up 5. What's my horizontal shift? I went left 6. Did I stretch or compress? I compressed 2/3. I used them all, so did I reflect? No, you did not, so none. Okay, same thing. Parent function this time. Look at those bars, folks. Those bars are what we're looking at, so that is the absolute value of x. Okay, so now it's negative. So that's going to be a reflection, and it's with the a value, so it's over the x-axis. The 6 is larger than 1, so it's a stretch of 6. Plus 9, it's going to the left 9 because it's opposite, and minus 2 is down 2. So let's fill this in. What is my vertical shift? Vertical shift means I've gone down 2 units. Horizontal shift means I've gone left 9 units. Stretch or compress means I'm going to stretch 6. In my reflection, I put reflect over the x-axis. Okay? So I've used them all. One more time. Parent function, it's what I have right there. That's the absolute value of x. Okay? So the negative means it's reflected and it's on the outside, so it's reflected over the x-axis. The 1/4 means it is a compress because it's a fraction. The -5 means it's going to the right 5, and the +8 means it's going up 8. Okay? Same thing. Parent function this time is right there. Square root of x. It's the one-armed bandit, right? So what's happening to this thing? Now, a couple things are happening here. This is the first one where we have to kind of work from the inside out. That negative means it's reflected, but this time it's reflected over the y-axis. And this +9 means that we're actually going to go to the left 9 units. The 4 is attached by multiplication, so that means it's going to be stretched 4, but it's negative, which means I'm also reflected over the x-axis. And then the vertical shift is this right here, which means I'm going to go down 3 units. That one was a hard one. Okay? Last one. My parent function is going to be x cubed. The negative on the outside means it's reflected. And since it's on the outside, it's over the x-axis. And the -5 means I'm going to the right 5. And I am not shifted up or down, and I am not compressed or stretched. Tonight's homework is 2-6 worksheet 1.